In the last video, we took a look at graphing quadratic functions from vertex form using those translation rules. Not all quadratic functions will come at you from vertex form. Sometimes they'll be written in standard form. Standard form being y equals ax squared plus bx plus c. We can graph a quadratic function from standard form by using some formulas for the axis of symmetry, the vertex, and then just looking for the y-intercept. So go ahead and get all of that copied down, and then we're going to put some formulas and our highlighters to work. So to find the axis of symmetry, the formula is x equals negative b over 2a. In our old Algebra 1 book, this formula used to be like the graphic design on the front of the textbook cover. So it's kind of an important deal. It's kind of a big deal in quadratic functions, this formula for the axis of symmetry. So if you haven't already noticed, the b comes from right here, but you're going to want to change the sign. So make sure that you do change that sign. Then the a is your leading coefficient. Whoops, oh dear. A is your leading coefficient. That goes down here. So that's where you're going to get those two numbers. All right, once you've found your axis of symmetry, then that is actually the x-coordinate of your vertex. So that just feeds into the vertex. Now to find the y-coordinate, you evaluate the function at negative b over 2a. So what you do is you plug in x into the function and you solve for y. Now the y-intercept is my favorite part. The y-intercept is just c. And where does c come from? C comes from right here at the end. So that's that. Each of those letters, A, B, and C, tell us something important about the graph of the quadratic function. All right, so something else to remember is that your maximum or minimum value, you'll have to look at the vertex and the direction of the opening. So how about some examples? Let's start with letter A. What we're going to do is we are going to sketch a quadratic function. If we know that the vertex is negative 3, 5, notice I'm kind of just abbreviating vertex. And I'm going to tell you that the y-intercept is 2. So we're going to sketch, and then we're also going to write the equation for this quadratic function. All right, so what do I know for sure? I know that I can go to the left 3, up 1, 2, 3, 4, 5, and that's roughly my vertex. Then my y-intercept is 2, so that's going to be this point right here. This is the vertex, negative 3, 5. My vertex lays on the axis of symmetry, so if I were to graph that axis of symmetry, then check this out. If I had my axis of symmetry, then I could take that axis of symmetry. I know that I have one point that's 3 to the right of it over here, and then what I can do is go 3 to the left over here, connect the dots using a nice smooth curve, and here I see that I have a parabola that opens downward. Okay, so roughly then, in vertex form, I can write this equation starting with a negative. My axis, or my vertex rather, was at x. I'm going to say plus 3, quantity squared. This shows me that left shift of 3, and then I had shifted the whole parabola up 5, so I'm going to add 5. All right, so there's my equation in vertex form. So keep in mind that that's in vertex form. And then now if I wanted to put it into standard form, well, I'd have to do a little work, but I can do it. Y equals negative, now I'm going to call this negative 1, times x plus 3 times x plus 3 plus 5. So all I've done so far is just expand x plus 3 quantity squared. We know that when we're squaring something, you're multiplying it by itself. That's what it means to square, multiply something by itself once. Now I'm going to FOIL. First, outer, inner, last. X times x is x squared. Outers, inners, and then last. I still have this plus 5 and the negative 1 times all of that good stuff. 3x plus 3x is 6x. And now I'm going to distribute in the negative 1. Negative x squared minus 6x minus 9 plus 5. I'm done here. Y equals negative x squared minus 6x minus 4. There should be a minus 4. Okay, so this is in standard form. That is standard form. Okay, now I'm going to take a minute and I'm going to graph both of my equations. So the first equation that I came up with was y equals negative the quantity x minus 3, no, plus 3, it was shifted to the left, x plus 3, quantity squared plus 5. Zoom 6 will take me to that standard viewing window. I'm going to go back to y equals, and in my next line, this red line, I'm going to graph negative x squared minus 6x minus 4. And then hopefully, oh, perfect, it fell right over top of that blue parabola. Now, what did we know when we began? We knew that the vertex was negative 3, 5. Yep, that's right here, negative 3, 5. They also began by telling us that the y-intercept was 2. The y-intercept is clearly not 2 right here, and that just means that I didn't consider that perhaps there was a vertical stretch or compression, and clearly there was. So what I am kind of missing here is some a value, missing an a value here and an a value there. But this is a close enough sketch. In the near future, we'll talk about how to actually I think it's tomorrow in section 4.3, how to exactly write your equations using that stretch factor of a. But in this case, what I wanted us to do was make a rough sketch, talk about where the vertex form came from, and then how you can get that standard form from vertex. We started this whole section, the whole chapter, with vertex form, and then everything else kind of just is like a cousin to vertex form. Standard form, it's a cousin to vertex form. Completing the square is a cousin to vertex form. All right, enough about that. Let's go on to example B. So I need to turn the page. I don't know about you. Do you still have enough room? Here is example B. In example B, what we're going to do pretty simply, pretty straightforward, is we are going to graph y equals negative 2x squared plus 3x plus 4. Okay, so I have to recall those formulas. Recall those formulas for the axis of symmetry, the vertex, and the y-intercept. All right, I got this. Axis of symmetry is first. Axis of, I'm going to abbreviate symmetry. So x equals negative b over 2a. In my case, negative 3 over 2 times negative 2. Do you see where I'm getting those numbers? If it helps you to highlight, please do the highlighting. Here's the 3. That was my negative b. Notice how I did the opposite. Over 2a, here's my a value. A was negative 2. Okay, so it looks like my axis of symmetry is going to be positive 3 over 4. The two negatives will cancel. 2 times negative 2 is negative 4. All right, that's my axis of symmetry. Now my vertex falls on the axis of symmetry, so 3/4 something. Now I need to find f of 3/4. So to find the function value at 3/4, negative 2 times 3/4 squared plus 3 times 3/4 plus 4. And frankly, that's a good job for my calculator. Calculator, here you are. I'm going to quit. I'm going to clear. I'm going to erase. Remember that to quit, you just go second mode. Second mode just takes you to that like calculator window. So I want it to go negative 2 times 3 over 4 quantity squared plus 3 times 3 over 4 and then plus 4. And when I hit enter, what did I get? Oh, 5.125. 5.125 is actually 5 1/8. I don't know, mode, let's see, no, second, no, let's see, math, I think. Yeah, if I go math 1, that'll turn my answer into a fraction, 41/8 or 5 1/8. I'm going to call it 41/8, I guess. But in the back of my mind, I converted that to that improper fraction to a mixed number, and I know that that's really 5 1/8. 41/8. How many times does 8 go into 41? Okay, and then last but not least, oh, let's see what happened here. All right, for example B, last but not least, I need my y-intercept. My y-intercept is my favorite part. It's just 0C, or it is really just C. You can call it C. You don't need to call it an ordered pair, because it's just where do you cross the y-axis, and that's pretty intuitive or pretty obvious. The y-intercept is C. So in our case, C is equal to 4. I'm going to highlight so that we're all on the same page here. This was C, and that was C. We need a graph now, and then we're done. So here we go. Let's graph. I'm going to go over 3/4. So if this is 1, this is 2, this is 3, this would be -1. 3/4 is going to be, 3/4 of the way between here and there. That's my axis of symmetry. I'm going to draw that in. Oh, my lines aren't very straight. Hopefully yours are a little straighter. Then I'm going to plot my vertex over 3/4 up 5 1/8. This is 5 1/8. We'll call this 5 right here. And then my C value is 4. So that's my that is my y-intercept. Now, keep in mind that this is 3/4 of the way from that axis of symmetry. So I want to be a little bit more careful here. So this distance right here is 3/4 of a unit. So to plot my other point over on the opposite side of this axis of symmetry, I'm going to go 3/4 of the way. Now what is 3/4 plus 3/4? 6/4, or 1.5. So this point right here is going to be at 6/4, or 3/2, or 1.5. All of those are equivalent numbers. Okay, equivalent fractions. So anyway, good enough. We've got that pretty accurately drawn. And then I'm just going to connect the dots like so. So I don't really know what the x-intercepts are just yet, but that's coming up in the next few days. So what can we say about this parabola now that we have it so nicely drawn? We can say that its domain will be from -infinity to infinity. Its range will be from -infinity to 5 1/8. And we can say that it has a maximum value at 41/8 or 5 1/8 or 5.125, whatever you want to say. All right, that's all I have to say about that.